Alright, boys and girls, today's lesson is lesson 5-9, Powers of 10. After this lesson, you should be able to say, I can read and write large numbers, identify the digits and their values. You already should be able to do that. I can use exponential notation to represent powers of 10. I can use expanded notation to represent powers of 10. And I can identify and describe patterns in a place value table. So let's quickly refresh the first goal, and that is I can read and write large numbers, identify their digits and values. Let's do a big number. Let's do 312,485,762. Remember from our lesson, or just our past lesson, every time you see a comma, you tell what it is. You tell if it's billions, millions, thousands. Obviously you don't here because these are ones. You don't say anything at the end here. So, okay, I can read and write large numbers, so should you be able to do this? Yeah, you should be able to do this one from our last lesson. So you should be able to read it as 312,485,762. You should be able to know that this is the 100 million place, this is the 10 million, this is the 1 million, or just million, sorry. This is 100,000, 10,000, 1,000, the hundreds, tens, ones. You know that the value of this would be 10,000. That'd be the value of this 1 here, it'd be worth 10,000. The value of this 4 here is just you put the 4 and then put zeros after it. It'd be 400,000. The 2 here, the 6 here would be 60. 2, just 2. The 7 is 700. The 5 is 5,000. The 8 is 80,000. The 2 is 2 million. I know you probably know all these, but I'm just trying to help you out here. The 3 is 300 million. So that's just a quick refresher on writing large numbers. Identify the digits and their values. So the next thing we're going to talk about are using exponential notation to represent powers of 10. Alright, some of you are probably like, what does that mean? So on page 130 in your math journal, you should see a chart like this. And at the top, it starts with the place value headings that you're used to seeing every day. You know the millions, you know 100,000, 10,000, thousands, hundreds, tens, ones. But everything below it is asking you to find different ways to say the words or say the numbers or show the numbers. So what I want you to do is I want you to fill in this top row right here. I want you to fill it in on your own. Remember, millions looks like this. Thousands looks like that. Hundreds looks like that. One looks like that. Once you fill in the next three, pause it, fill it in, unpause it. Alright, so hopefully for 100,000, you did that. 10,000, you did this. Hopefully your zeros look better than mine. Tens, you just did 10. Okay, now we're going to start showing you new ways of doing it. The next way is a little bit different. If you look at each of these numbers on the top row you filled out, they are 10 times bigger than the number below it, the number to the right of it. So millions is 10 100,000s. So 100,000s will be 10 10,000s. And 10 is 10, or sorry, 1,000 is 10 100s. 100 is 10 tens, you know that. Ones is 10 tenths. That's kind of a tricky one, but if you know tenths and decimals, 10 tenths will get you 1. So I want you to try to fill out the next two. I want you to fill out 10,000s and tens. So pause it, do it, unpause it. Alright, hopefully for 10,000s you did 10 1,000s. And you're supposed to put an S, but it's just my big old marker here, pencil. It's kind of tough, but. And then for tens, hopefully you did 10. This is probably the easiest one. 10 ones. Okay, I want you to pause it. Study the next row here that you can work on, and try to think what it might be. So the next row are considered powers of 10. So numbers like 100, 1,000, and 10,000 are called powers of 10. They are numbers that can be expressed as products whose factors are 10. So we're going to do a couple of these together. Obviously, 10 1,000s already tells you it is 10 times 10 times 10 times 10. For 100, you know it's 10 times 10. And I want you to see the pattern here. 10 times 10 will give you 2 zeros. How many zeros do you need to make 100? 2. 10,000s will give you 1, 2, 3, 4 zeros. How many zeros do you need to make 10,000? 4. So we've learned this before by using a extended multiplication. You just multiply all the easy digits that you see and then throw all the zeros on at the end. So I'm going to do, let's see, I'll do millions this time for you. Millions has 6 zeros in it, so I'm going to need 6 tens. 10 times 10 times 10 times 10 times 10 times 10. So I have 6 zeros on top of my 1 that'll give me my million. So I want you to fill out hundred thousands, thousands, and tens, and I'll show you. I'll go over the answers with you. All right. So 100,000s has 5 zeros. So that means how many tens? 1, 2, 3, 4, 5. 5 tens. That'll give you 100,000. Okay, thousands is 3 zeros, so we have to do 10 times 10 times 10. Notice how these are all powers of 10. Powers of 10 means you have to multiply 10 over and over and over to get to the number. So, and the last one is just 10, because it's not 10 times anything, it's just 10. It's simple. Okay, so the last row is where we talk about repeating the factor 10. Okay, this is where we start to learn about our exponential notation. Okay, these I think are the easiest because all you do is you take 10 and you put a little number on it based on how many zeros you have. Actually, they're how many tens you have, but an easy way to learn it is just count the zeros. So 10 to the power of 5 means it would be 10 times 10 times 10 times 10 times 10. It means 10 times 10 5 times. So on thousands, you notice it's 10 times 10 times 10, so it's 10 to the power of 3. Hundreds is 10 times 10, so it's 10 to the power of 2. And I will do tens for you here because 10 to the power of 1, because it's 10 and it's not multiplying another 10. And a tricky one is 1, 10 to the power of 0, because there aren't any, you're not multiplying by any tens at all. So why don't you work on 10,000s and millions place on your own and unpause it and we'll go over the answers together. Pretty easy. Alright, so millions would be 10 to the power of, well, let's see how many zeros we have. We gave it away there. 6. Okay? And then 10,000s, 10 to the power of 4 zeros, 4. So this is exponential notation. This is how you can explain big numbers, and this will be on your test. Well, the next thing we're going to do is we're going to go over expanded notation to represent powers of 10. So expanded notation is kind of, it's actually really kind of easy, but it's kind of tricky. So I'm going to give you a number, 24,313. Expanded notation using powers of 10 are basically telling you this is 2 times 10,000, because it's 2 10,000s, plus 4 times 1,000, because it's in the thousands place, plus 3 times 100, plus 1 times 10, plus 4. And if you worked it all out, you get 2 times 10,000 would give you 20,000, plus 4,000, plus 300 plus 10 plus 4, and the answer would get you there. So expanded notation is just another way to, I guess, stretch your learning a little bit. It's actually really easy, and you probably won't use it a whole lot, but it'll help you really understand a number and be able to break a number down. So I'm going to give you one to do on your own, and I want you to write it in expanded notation. And we'll do make this one kind of easy for you. So pause it, work it out, and I'll show you the answer. All right. So hopefully for the 3 you did 3 times 1,000 because there's 3 1,000s plus 1 times 100 plus 5 times 10 plus 1. Pretty easy. 3,000 plus 100 plus 50 plus 1 equals 3,151. Okay, one more, and we'll be done with this. All right, do this one, 27,422. Pause it, do it, unpause it. All right, hopefully you did 2 times 10,000 plus 7 times 1,000 plus 4 times 100 plus 2 times 10 plus 2. That would give you 20,000 plus 7,000 plus 400 plus 20 plus 2 to equal 27,422. All right. Hopefully you understood the lesson.